So as a previous slide that we were on this slide, that solubility of any solute depend on the two factors. Number one is intermolecular forces and number two is energy changes. So intermolecular forces we have already studied in chapter number 11. So I will say that you can review that in a very detail, but in a very short way I just want to go very quick summary that there are two types of forces which is called intramolecular forces and intermolecular forces. Intramolecular forces are within single molecule, for an example ionic bond, covalent bond or metallic bonds. So these are example of intramolecular forces and they are very strong than intermolecular forces. For an example, sodium ion and chloride ion are held together by intramolecular forces. Intermolecular forces are between two different molecules. They are weaker than intramolecular forces. So here shows example of HCl. The hydrogen atom and chlorine atom are held together by covalent bond and the force is called intramolecular force, and the two molecules of HCl are held together by intermolecular force. There we have studied there are four type of intermolecular forces: dipole, ion dipole, hydrogen bonding, dipole dipole and dispersion. So these we have already studied in the previous chapter. Please review those. Here just I am giving you very quick summary that London dispersion occur in the all molecules but are most significant in non-polar molecules. So non-polar molecule have London dispersion intermolecular forces. Dipole dipole always occur between two polar molecules. Hydrogen bonding occur between the dipole. This is also another example of dipole dipole interaction, but it occur with the hydrogen which must attach with the oxygen and nitrogen and fluorine. So either hydrogen is attached with the oxygen or nitrogen or fluorine, that hydrogen can form another bond with the oxygen or nitrogen or fluorine, then it will be called as a hydrogen bonding. Ion dipole occur between the ions and polar molecules. And ionic forces, basically ionic forces are between two ions oppositely charged, and this is an example of intramolecular force. But in case of if there is a polyatomic ion, so maybe we can consider there is some intramolecular force. So this is the list where which shows their strength. So ion dipole, ion intermolecular forces are very strong compared to ion dipole, then hydrogen bonding, then dipole dipole, then ion induced dipole force, and then dipole induced dipole London dispersion. So here is some example shows sodium ion and water molecule, water and methanol, they have hydrogen bonding. Water and DCM or dichloromethane is have dipole dipole interaction. Sodium ion and carbon tetrachloride is example of induced dipole and ion. Dipole and induced dipole, water and benzene, carbon tetrachloride and benzene, this is example of non-polar molecule London dispersion. So here is another important slide that what is the dissolution process and how sodium chloride dissolve into water. And whenever we add any solid into the solution, basically the process is called solvation or dissolution. What does it means? Basically this red ball and white ball, this represent the water molecule, and if you see the water molecule, we have seen in the previous chapter that what oxygen is have more electronegativity, so it have slightly negative charge, and hydrogen have slightly positive charge, so they have dipole. So in this diagram, when the shows that red ball represent the oxygen and white ball represent the hydrogen, and this green and purple balls, the solid cube, represent the sodium chloride salt. So what happened, basically once you add the solid sodium chloride into water, the oppositively charged ions are attracted by the water molecule with their oppositively or charged polar groups. So here you can see that sodium ion is small and comparatively chloride ion is bigger. Chloride ion is surrounded by the hydrogen part of the water molecule, and sodium ion is surrounded by the oxygen part of the water molecule. So this process is called solvation. Solvation means we are making solution of solute to solvent. So solvation means whenever we dissolve any sodium chloride into water, basically this is called sodium chloride dissolution, or there is some heat energy is also involved, and that is called delta H, or enthalpy, change in enthalpy of dissolution. So solid sodium chloride, when it dissolves in sodium ion and chloride ion, for this process to occur there must be separation of solute. So first separation of solutes. So in a sodium chloride dissolution or delta H dissolution means that whenever we have to dissolve any solute, some energy is required, that is called separation of solute particle first will take place, then separation of solvent molecule will take place, that will be represented by change in enthalpy of solvent, and then formation of solute and solvent interactions, that will be called delta H mix. So total delta H mix of the solution will be equal to delta H of solute plus delta H of solvent and plus delta H of the mix. So this is the way energy is involved in making a solution. So we'll see in another slide that there is some thermochemistry is involved. For this you have to review the chapter number 5, and this is again I will say that you have to review my general chemistry 1 previous chapter videos. So I will add the link here in the description, you can review that one. The change in the heat of the content pressure is defined as the change in enthalpy. So enthalpy means change in the heat at the constant pressure or atmospheric pressure, basically we can say. So in enthalpy, change is represented by delta H. A reaction is endothermic if the heat is absorbed, or exothermic if heat is released by the system. So endo means heat is coming in, and exothermic means heat is coming out or releasing out. So sign conversion, delta H for positive delta H means endothermic, you have to provide the energy. Negative delta H means exothermic, you will get the energy. So this is example, like you can also understand that positive H means endothermic means deposit money, deposit dollars into your account. So you are adding money into your account, you are adding any energy into your account, so balance will be positive. And withdrawal of money from account will be example of negative delta H or exothermic. So you can think about if we have water, liquid and to steam. So basically we have to convert water into steam, means you have to provide energy. So this will be like endothermic process. Water, liquid to solid means we want to freeze the water into ice. So we have to remove the energy so that they can freeze it. So this will be like exothermic process. Methane gas, when react with the oxygen, form carbon dioxide gas and water. This is a burning reaction. It's called combustion reaction. Whenever any hydrocarbon means carbon and hydrogen molecule that contain carbon and hydrogen is called hydrocarbon. Whenever they react with the oxygen, it's called burning reaction, combustion reaction. And when they react, whenever any gas burn, hydrocarbon burn, they produce carbon dioxide gas and water molecule. So this is also example of exothermic reaction. Now another two common examples are heat pack and cold pack. So here an example of like magnesium sulfate heat pack, right? So this is a heat pack process. What happened in this heat pack? Energy of the dissolution process. What happened? You have separation solute which will separate. In this graph that shows the energy is going up or enthalpy change is up, and then so this first box shows that you have solute like magnesium sulfate. When it dissociate or when it form into separate solute particle, you have to provide some energy. And then water, or this is water, this is a solute. So basically you can see solvent and solute, right? So solvent is this water and then this is solute. So each molecule, when you have to separate, you have to provide some energy. Basically you have to provide energy to break the intermolecular forces. Once you will provide energy, they will be separated, they will mix together, and then they will form a solution. If the total solution have less energy than the individual solute and solvent energy, then basically you will get some energy out, right? So here you can see in this picture, this shows that delta H of the mix of the solution is lower than these one, lower than individual solute and solvent. So it means you will get the some energy out. So heat pack, they will give you hot, warm, you will feel on the skin hot because it is providing some energy to your body. And this will be equation, delta H of the solution is less than the delta H of the solvent and delta H of solute. So this is the way energy is involved in the heat pack. Let's see how the energy is involved in the solution in the cold pack. So energy in dissolution process, ammonium nitrate is an example of ice pack. So ice pack contain ammonium nitrate and that is called the solute. When so here is once again how this ammonium nitrate will produce the ice pack. How will it will make ice pack? So basically solvent will dissociate into separate, then solute will dissociate, and you have to provide some energy. Once they mix together, the energy will come down, and in this solution, if you see, the favorable process is up to here only. So energy is still have higher energy. So basically in case of cold pack, to mix solvent and reactant, you have to give more energy. This energy is much required. So once you will put this ice pack into your skin, basically the energy will come from your body to this ice pack. So it will get energy from the environment, from your body. And the energy equation is related to here. Delta H solution is more than the delta H of solvent plus delta H solution. So this we can summarize in this graph also. This relationship of enthalpy is called Hess's law, which we have studied in the chapter number 5. So where this shows that if we have solvent and solute, first you have to give energy to dissociate the solvent, and then separated solvent and solute. Once they will mix together, they will form the solution, and if the solution have the less energy than the individual solvent and solute, you will get the energy out. But in this graph, this shows if the solution have more energy than the solute, you have to provide some energy. So this will be example of ice pack. This is a graph for heat pack. This process is called endothermic because you have to provide some energy. This process is called exothermic, you will get some energy. So these are some examples about the more energy and intermolecular forces related to this solution process. And in the next slide we will study about more what are the other properties of solution.